Okay, my rant. Here's my rant. First of all, I'm only talking to a few students. Second of all, it's not just this class. I'm doing this in all my classes. Okay? Number one, the bonus question. What does it say about challenge questions on tests? What is the procedure for having challenge questions on the test, or something that you think you got right? Can somebody answer that?
Estimate after class.
Okay, does that say anything about emailing me or texting me or sending me messages over Teams, or does it say just ask to meet me after class?
Estimate after class.
Just see me after class. I have gotten at least 6 emails. Not for I don't even know. I can't even tell you who they are, so I don't even know what class they're in. Okay. I do things for a reason. Okay. One of the reasons I do that is so I won't forget. Okay. You send me an email or a message or a text message, or that doesn't register with me. I have to talk to the student. Okay. And it's not much talking because the student doesn't talk much unless they want to. I just look at the test, I review it with them, you see it, I present screen, you see it, a one-on-one, you know, I tell the student I'll chat with them after class, and I pull them up and we chat and we look at the test. It's simple as that. But I bet I've gotten 6 emails, and I'm six classes. 6 emails. I don't know which classes they come from. I just ignore them because that's not the rules. The rules are, if you have a question about a test, you see me after class. Second thing about the rant. Second thing on my rant agenda. And again, I'm not talking to this class. I'm talking to all my classes. I'm going to do this all day today and all day tomorrow. Do not whine and complain to me about all of the work that I'm doing or all the work that I'm assigning, and I look at your homework and you haven't done any work in 2 weeks. My Labs Plus records everything you do, how many problems you work, when you worked them, what hour you worked them, what day you worked them. So when I hear a student coming to me and complaining about this or this or this, and I just don't understand, and I go to the YouTube videos and nobody has watched the videos, and the person is complaining has not done any homework in 2 or 3 weeks, does that person really have a leg to stand on? My classes operate off of the people that do the what?
The work.
The work. I told you the first day of class, I said, my classes are gauged on what work you do and what questions you send in. If you don't do homework for 2 or 3 weeks, you have no idea what kind of questions to ask. Okay, again, I'm talking to probably 1 student in here, if I'm talking to anybody. 1 student in each class. I got 6 classes. I've gotten about 6 emails pertaining to these 2 issues, maybe 7. Okay, so please don't send me an email saying this, this, or this about the class and the material when I look back at your MyLabs Plus and you haven't done work in 2 or 3 weeks, and then I go to YouTube and 120 whatever class or 110 or whatever, there's like 1 view. And I guarantee you that one view on the material that you're complaining about, I guarantee you that person that hadn't done any homework in 2 or 3 weeks, I doubt very seriously that that's that person. If I'm getting 2 or 3 people complaining about material in a class, I should see about 3 or 4 views or more on the YouTube video. But anyway, now that's my 2 rants. My next thing is, and I'm going to show you this right quick. These are my classes for next semester. Well, I've got one more, but she hadn't decided what I'm going to teach. It's either going to be another 120 or it's going to be another class. Now, why am I showing you this? You've already got 120. Yep. But some of you may be in the major that needs 2 maths. And if you are in that major that needs 2 maths, like nursing or, or associate in arts, or you're going to transfer in arts and they like 1 or 2 maths, that 103 is the sister or the co-requisite that a lot of students take with the 120. Okay, I'm just telling you that. You might need it. You might not. But you might need a class, a math or a science to finish your degree here at Tech. That's a good class. Why is it a good class? Because you've already done 2 units of it. The first and second unit in 120, I teach the first and second unit in 103, probability and statistics. The first unit is statistics, just like our class. The second unit is probability. You cover the same work, the same problems as you've done in here. So technically, you're really, half the class you've already done. So that's what I tell students. A lot of students take Math 120, usually end up taking the 103 because they end up transferring and they got 2 maths, and that helps them out when they transfer to another college. So I just wanted to mention that to you. Write that CRN number 43176. I don't know why I bunched it up like that, but okay. Does anybody have any rants or concerns or anything like that since I'm in a rant mood? Anybody? Anybody got a question about this class? Everybody seeing their advisor okay? Y'all seen your advisor for pre-advising?
Yes.
Good. Anybody got any questions about advising or classes or my rant? Anybody want to rant back at me?
I have a question about what's on the screen. What's that Synchro DL?
What's what?
The Synchro DL under
Technically,
Math
the way I'm teaching you on Wednesday and Friday.
Okay.
A hybrid is when I meet with you. And a synchronized DL, that means synchronized distance learning. That means that the way I'm teaching you on Wednesday and Friday. A synchronized DL teacher is one that can do pretty much anything that he or she does in the classroom. They can do it from home. Just like I've got my whiteboard, I've got my projector, I've got my TV monitor, I've got my document cam. There's nothing really different about the way I teach here than the way I teach in the classroom. Does that answer your question?
Yeah, it does. So that class would be all teams.
Yes. In other words, you could take this class from home if you wanted to.
Perfect.
So, where do you live, Miss Stewart?
I did live in Anderson, but we just moved to Pickens. So.
Well, yeah, I'll be glad to have you. Anybody else got a question? Okay. So if you do have a question about a test question, and I don't know if anybody in here did, send me after class, or you can send me a message and say, Hubert, when's a good time we can team together, or I can call you on Teams and we can discuss my test. That's fine. I'll be glad to reply to that. But don't send me an email with 15 concerns about your test because I'm not going to read the first one. When I saw a couple of those emails, when I saw I have a couple of questions on the test that I believe I got right, I just go to the next email. I don't even look at it because that's not my procedure. Okay? My procedure, I've told you my procedure. I don't do your procedure. I do my procedure. And as far as the complaining, I'm sorry. I've got about 80% of my students that are got, C's or above. And if you have a problem with the way I'm doing things, you're in the minority. Okay, again, that's not just to this class, that's to the rest of my classes also. I'm going to go through this speech at the beginning of the class on all my classes. And somebody's going to say I'm talking to them. No, I'm talking to the 6 or 8 people that sending me emails acting like I'm the villain. And I'm not the villain and not following directions. Okay, all right, I'm officially over my rant. Now, got 2 questions sent in. Here's the first question. 6.1 5/3. Is this a test question? Oh yeah. Anything having to do with discrete and continuous is a possible test question, and it's a possible standardized test question. And basically what they're asking you is this discrete or continuous? Now, before I get started, let's go over discrete and continuous again. What is the one-word definition for discrete? Starts with a C.
Countable.
Count. What is the one-word definition for continuous? Starts with an M, as in Mike.
Measure.
Measure. That's about the 4th or 5th time. No, I think I've done it twice in each, 2 or 3 times in each class that we've gone over it. Why? Because this is something that a lot of people just don't think about. Okay, so I have to say it over and over and over. Discrete, you count. A good example, eggs. You don't measure eggs, you count eggs. You measure the amount of milk in a carton. I don't know how to spell carton. How do you spell carton? I don't know how to spell carton. Is that the way you spell carton?
Yeah, that's right.
You ever look at a word and it don't look right?
Yes.
Okay. All right. I just wondered if it was me. All right. That didn't look right. So anyway, and I just remembered, I don't know how to spell carton. That's one of those words you don't use a lot. Anyway, so discrete and continuous. So let's look at this one. Oh, there's that key word, number. Number of people. You know that's discrete right off because it says number. Number of people in a restaurant. And that gets this one right here. The only other possible answer is this one. And that's not true. Why is it not true? Because this includes fractions and decimals. And you can't have fractions and decimals. Can't have a half a person in a restaurant. It's like half a household. Okay? The time required to download a file. Well, let me ask you a question. If Mr. Germain downloaded the same file as Miss Loftus on 2 different computers, would it be the same exact time?
No.
No. If it's not the same exact time, then that means it's measured. So it'd be continuous. Let's see what the other one. Can't be continuous and count 1, 2, 3, 4, 5. Continuous means that you measure it. And measured means any value over 0. 0 is midnight. Can you have 1220? Can you have 120? Can you have 145? Can you have 230? Yes. You can have any number above 0. Time is measured. Why is it measured, Hubert? Well, look at your clock in the kitchen. Is your clock in the kitchen the same as your clock in the den? Sometimes they're not. Time is measured. It's continuous. That's a good test question. I like that question. And a lot of people say, well, Hubert, you count hours. Yeah, but what's in hours? What's between hours? What makes up hours? Minutes and what?
Seconds.
So can I have 2.5 hours? Yes or no?
Yes.
Can I have 2.5 kids?
No.
No.
And that's the difference. That's what you need to ask yourself. Can I have 2.5 gallons? Yes. Can I have 2.5 eggs? No. Now, I just ate eggs this morning. I just made me an omelet before class. Okay? I could divide that egg in half, but it's not going to be precise. I mean, you could say 2.5 eggs, but you count eggs 1, 2, 3, 4, 5. Okay? Good question. I like that question. Next question. 6.1, 18/6. Is this a test question? Oh, yes. This is the heart of 6.1 right here. We're going to do this question on the spreadsheet. And I'll show you how to do it on the calculator. Now, do y'all see how this went? I taught you, let's see, what was Friday and Monday, we went over 6.1. And I don't know who sent the first question, Miss Hicks, and who sent this question? Miss Griffin. Y'all are doing what you're supposed to. You're doing your homework, and then you send in questions. That's how I do things. Okay? I'm sorry. I'm still ranting, aren't I? I'm sorry. I'm being a bitch this morning. All right. I think I'm entitled. I mean, ain't I entitled to bitch a little bit? Ugh. There's people say they couldn't be a teacher. Well, I can be a teacher. It's just sometimes the 1% gets to you. Sometimes they just get to you. Okay, I'll shut up. Let's go and hit Excel. Now, what's the first two things we do with a probability distribution before we even start? What's the two tests?
See if the probabilities equal 1.
Say again?
See if all the probabilities equal 1.
Exactly. Well, that looks strange. Oh, I didn't highlight the whole group. Hold on. All right, there's your probabilities. Now you can type them in your calculator or you can put them on a spreadsheet. Go ahead and do that. Now, I have no idea what the question is asking. I'm going to do everything that I expect for you to do in 6.1 on this question. So therefore, you can write this question in your notes and study it and say, if I'm going to do good in 6.1 on the test, I need to make sure I understand everything on this problem. That's what you need to put at the top of the page on this problem. Because if you can do what I'm doing on this problem, then you can do anything in 6.1 that I will test you on. Okay, so as Ms. Stewart said, one test is to make sure that all of the probabilities equal what?
1.
1. Good job. Ding! Now I'm going to highlight that. We'll highlight that green, meaning that we have to do a test there. Now, what's the second test? Each probability, what?
Has to be between 0 and 1.
Exactly. So that means no big numbers and no negatives. So everything is between 0 and 1, no negatives, no 1.2s, no 1.5s, no 1.8s, 2.3s. All of these are between 0 and 1. Think of change in your pocket.
I got a question.
Yes, ma'am.
What if it is a negative?
Then you say cannot be done.
Huh?
You say cannot be done, or the question will ask you at the bottom, is this a binomial distribution? The question will give you the answer of, is this a probability distribution or not?
Okay.
Most of your questions that we do like this, they are going to be probability distributions. Okay. I will not give you a question to tell you to find the mean and the standard deviation if it's not a probability distribution. But do you remember those 3 questions we did? One was 0.97, one had a negative, and the other one was a binomial distribution. Do y'all remember those?
I don't remember it, not really, but I do remember having a problem on homework that had a negative in it.
Let me show you right quick. Back up. There they are. Remember this one? Okay, this is the question that will be asked, Ms. Hicks. Is the following a probability distribution? And then it'll say you'll have a multiple choice, yes or no. That's the type questions that they'll throw a negative in on you, like this one. Okay.
Okay.
And then this one, this one is not a probability distribution because it equals 0.97. If you add all these up, it's 0.97. So you would say no. This one has a negative, so you would say no. This one is because everything is good.
I found it. I see.
That's the type question I would give you on a test. It would say, is this a probability distribution? Now, the difference between these 3 questions and the one we have now is this one is asking you to do math. And if there's a probability distribution asking you to do math, chances are it's going to pass both tests. Okay? So this one passed both tests, so we can go. Now, what are they going to ask you for? They're going to ask you for the mean and the standard deviation, or IM. So let's go back to the handy-dandy formula. And our mean of a probability distribution is equal to the summation of x times what? P of x. Now, we went over this the other day. And our variance is equal to the summation of x squared times P of x. And I'm going to put that in brackets. Minus the mu we just got squared. Now, those are the 2 formulas that you're going to use in 6.1. So I'm going to make this small. Well, we'll make it smaller than that. There we go. And put it over here. And it's going to disappear. I'm sorry. Okay, so there, let me leave it on the board. Where did it go? There it is. Okay, I'm going to leave that up there a couple more seconds. That way, those of you that didn't write it down in the last two classes, well, we went over this Friday. We went over this Monday. So if you wasn't here Monday, you didn't get that one. I don't know who was here Monday and who wasn't, so I'm not trying to pick on anybody. All right, so we got to find x times what? P of x. So I'm going to go over here, and I'm just going to make a big column right here, and it's going to be called x times what? P of x. And that's equal to 0 times that number, and copy it down. And what are we going to do? Let's go back to our formula. What are we going to do to x times P of x? What does that funky E mean?
Add it.
Add it all up. And that number right there is your mean. Now I'm going to color that. Let's go with a pretty color. Let's go with magenta. Can't go wrong with pink or magenta. I don't really have a pink. Well, we'll go with that. And that is your mean. So I'm going to go down here, and I'm going to put mean equals, and I'm going to put that number right there. And highlight that pink, or whatever. That's more of a mauve, but we'll go with pink. Y'all are impressed that I know my colors, aren't you? I figured you were. I'll even put brackets around it. All right, so we found our mean. Now what do we need to find? The variance. The variance, let's go back to our formula, because we need to read our formula in case we don't know what to do, because our formula is what to do. So what do we not have? We've got mu, we just got that. We got P of x. What do we not have?
X squared.
We don't have x squared. So that means we got to make a new column. X squared. Now you could do this in your head, but I'm just going to make another column. 0 squared. And I'm going to copy that down. So you could do those in your head, but I just did it just to show you. And now I need to go back to my formula. X squared times what? P of x. So I'm going to make another column right here. And this one's going to be called x squared times P of x. So I'm going to take that number and multiply by P of x. And copy that down. And that's going to give me this number. I'm going to color that kind of orange. And I'm going back to my formula. And I have just found this right here. And I'll highlight that in orange. So that orange number that I just highlighted orange is equal to this part of the formula. So I'm going to take my handy dandy pen and I'm going to put 1.363 minus 0.911, and I'll do that in that mauve color. God, what are the things I do for y'all? 0.911. Actually, that doesn't look like this color at all. That looks like a red. Anyway, I suck. I'm such a disappointment. All right, so I'm going to go with the variance here. Variance equals, what the heck? Variance equals this number minus parentheses this number squared. Here's my variance. Now, variance is not that important. What is important is the what? Standard what? Deviation. And somebody tell me what the relationship is between the variance and the standard deviation. What do I take the blank of the variance to get the standard deviation?
Square root.
Thank you, ma'am. I can always rely on interaction from Miss Stewart. Thank you. Standard deviation is equal to the square root of the variance. And we have been talking about that since the first week of class, or the first unit. Okay, so all I do now is I take the square root of 0.533079 or raise 0.533079 to the 0.5 power. That's the way I do it. So standard deviation is equal to this number raised to the 0.5 power. And that is my, we'll color that blue. Those are my two numbers that I want in 6.1. .730123. So I'm going to take my handy dandy pink highlighter and I'm going to highlight the two numbers that I want on the test. Now, they may ask you to graph this also. How do you graph it, Hubert? Well, you highlight these two columns. You hit insert, just like we've been doing all semester. And I'm going to connect mine. And there it is. Now, if I was to put the center, let me take my handy dandy whiteboard. Okay, didn't come up. There it is. And let's say I make my center. What's between 0 and 5? 2.5? Oh, that sucked. Hold on. Let me undo that. Go here. So there's my center at 2.5. Somebody tell me what kind of curve my data is making.
Skewed right.
Skewed right. Good job. Thank you for your interaction. I appreciate it. So our data our data is skewed right. Also, where is our biggest probability? What's our largest probability in our data? Somebody besides Miss Stewart. What is our biggest probability?
0.567.
0.567. Turn, who was that? Thank you, Miss Griffith. 0.567. What does 0.567 correlate to? It correlates to 1. So 1 shows up the most. So this is a single mode. So let's write that down. Point 567 corresponds to 1. 1 shows up the most. Therefore, single mode. If 0.567 showed up with 2, then that means 2 shows up the most. That means bimodal. And anything above 2 would be polymodal. You could say trimodal. If 0.567 was at 3, that means 3 shows up the most. That means trimodal, but single mode. Now, I'll be honest with you, I don't know what else that question could ask. I've given you everything in 6.1 that question could ask. So I'm going to leave this on the board for a few seconds, and hopefully y'all will, have a note in your 6.1 notes. If you can do everything I just did here, then you can handle 6.1. Let me go to the handy dandy calculator. Oh, I'm going to rant again. I get people fussing about can't use a calculator. Well, don't I show y'all how to use these calculators and I record it on my videos? What can you hit on a video if you don't understand something? What can you hit?
Rewind.
Rewind.
Rewind. I'm not understanding some of the complaints that I'm getting. I guess I'm crazy. I don't know. I mean, one of the reasons that I've been recording my classes for 6 years, I've been doing it for 6 or 7 years now, is because the students can go in and whatever they didn't get, they can go over and over and over by hitting the rewind button. But then I see classes and nobody's watched the classes. So if nobody watches the classes, to me as a teacher, that means that everybody understands the material. Or if they don't send in homework questions, they know the material. But heck, some of the people aren't sending homework questions in because they hadn't done homework in 2 or 3 weeks. Anyway, I'm sorry. All right, so where is my question? My question is in Excel, and there is my, all right, so we're going to type these in, clear. I'm going to go to Stat, Edit, and I've already got 0, 1, 2, 3, 4, 5. I think I did this with the other class yesterday. All right, 0.277, 0.567, 0.129, 0.023, 0.003, and 0.001. One other thing I'd like to say. What if you don't get enough out of 120/24 videos? What have I included on y'all's channel? If you don't get enough out of my videos for 12024, what can you use? The 12029 videos. All right. So let's say I want to plot these. Then go to second, stat plot, which is y is equal. Click enter to go into that number 1. Hit on. And I'm going to use the second one because it's got a line between it. And graph. There it is. Now I can't see it all, so I'm going to hit zoom and go down to trig stat. There it is. Now let's find all the information that I just calculated. Go to stat, calculate, first variable stats. Enter. Change the second one into L2, shift or second 2, and calculate. There is your mean, 0.911. And there, sigma is your standard deviation, 0.730123. How's everybody feel? Now see, I don't have any communication. So what does that tell me? That y'all understand the what? Y'all understand the material. And in 2 weeks from now, I'll get somebody complaining about they don't know how to use calculator. I'm sorry, not in this class. Y'all don't say nothing. So y'all don't even complain. So I don't know. I'm preaching to the choir in this class. All right. So that's 6.1. Everybody good? Let's look at the question and see what we can answer. I'm going to erase this. There. This is a discrete probability because all the probabilities are between 0 and 1 and the sum is equal to 1. Okay, we did that first. And we skewed right here. This is skewed left. This is skewed left. This is neither or neither. So it'd be B. The distribution has one mode because 5, 6, 7, 1 shows up the most and is skewed right. And the mean is 0.911. Says do not round, which is equal to 1 marriage. 0.911 rounds up to 9 or 1. So the one that shows up the most, the mean is 1 marriage. Because you don't want, I don't think anybody wants 2 or 3. I do know somebody that's had 3. I just don't see it. I've had 1, and I don't know if I want another one. Which of the following interpretations of the mean is correct? I don't agree with this, but the answer, let's see, if many individuals, I don't think many is a good word here, but that's the answer. Just remember many. If many individuals, I think it would be if any number. I don't like the word many in stats. I don't like it. All right, check answer. And the round to 1 decimal place, that would be 0.7. That's a good test question. What is the probability that randomly selected individuals was involved in 2 marriages? 2 marriages is what? 0.129. Here they're just asking you if you can read the table. 0.129. At least 2 marriages. What does at least 2 mean? We went over this Friday. What does at least 2 mean?
2 or more.
2 or more. So add up 2 or more. So that would be 0.129, 0.152, 0.155, 0.156. Y'all add them up for me. Tell me what you get.
.156.
I tell you what. That's it. That is about 5 or 6 test questions I could ask you right there. This one is a test question. This one is a test question. Of course, that goes with this one. The mean is a test question. I don't care anything about this question, though. I don't like the word many. This is a test question, and these 2 are test questions. So 1, 2, 3, 4, 5, 6. There's 6 test questions that I would like to give you on this one. Okay, so if you can do this question, you can handle pretty much anything I give you out of 6.1. Capiche? Does everybody understand? Does anybody have any questions?
Capiche.
Okay, good. I'm not Italian. I know y'all think I am, but I'm not. I'm Black Irish. My descendants, my ancestors were Black Irish. That's why I don't have red hair and fair skin. But anyway, I would love to be Italian. If I had to pick any, I think Italian would be. They got the. I love their language. Capiche, capiche. I think that's Godfather thing, old good movie. All right. And nobody says anything, of course. All right, so we're going to move on. We're going to move on to other things. 6.2. I ain't got much time, so I'm not going to spend much time in 6.2. It'll probably be Friday. So let me find 6.2. I had 6.2 pulled up. There we go. Okay, 6.2. The binomial probability distribution. Okay, your regular distribution was the regular probability, was a probability distribution like the problem we just did. Okay, a binomial probability distribution is when you actually use n, p, and x, and n and p. I'll show you that in just a minute. Okay. The experiment is said to be binomial if fixed number of trials. Write that down. Fixed number of trials. The trials are independent. That means one doesn't have anything to do with the other. Thinking of flipping a coin. Flipping a coin 50 times, the probability of tails has nothing to do with the probability of heads. They don't influence each other. The gravity, the flipping, when it hits the ground, that's what has to do with it falling on heads or tails. There are 2, that's what binomial means, 2 outcomes, meaning success or failure. Probability of heads would be success because I said so. Probability of tails would be failure. And the probability of success is fixed for each trial of the experiment. When you flip a coin, it's going to come up heads or tails. That's it. There's no in between. So I think it'd be good for you to write down flipping a coin for an example on this. Fixed number of trials. Well, I'm going to flip a coin. Excuse me. I'm going to flip a coin 50 times. Fixed number of trials, that would be 50. N is equal to 50. The trials are independent. The coin falling on heads has nothing to do with the coin falling on tails. There is no influence from heads or tails. It just falls the way it falls. There are two mutually exclusive outcomes, heads or tails. And the probability of success is fixed. You're either going to get heads or you're going to get tails. There is no in between. Kind of 3 and 4 are the same. There's N. N would be 50 on that example I just gave you. And of course, the complement is 1 minus, okay, we'll get to that in just a minute. And X be the outcomes. Okay. Basically, in this section, everything revolves around N, P, and X. N is always your largest number. In the problem I gave you, I said 50 flips. Okay, that would be N is equal to 50. P is usually the percentage or probability, because it has to be written in a decimal. And in the previous problem, the probability is 0.5. You got a 0.5 of heads and a 0.5 of tails. And X is going to be the number of additional flips. Let's say I flipped the coin 50 times and I got a 0.5 probability. What would happen if I flipped it an additional 10 flips? What would the probability be? Okay, so this is the type question you're going to see in this 6.2. And the other is finding the mean and the standard deviation of N, P, and X, and we'll get to that in just a second. Which all this math is real easy, and you do the NPX, you do that in the calculator. This is, you're going to do this in the calculator. And this down here, you can do basic math in your head. And I'm trying to think. The mean is equal, I think it's NP. N times P. And then the standard deviation is equal to the square root of NPQ. And Q is the complement of P. Okay, so this is 6.2. Now it makes a whole lot more sense when you see an example, so hopefully they're going to show us an example here in just a second. And I'm out of time. I suck. All right, so that's where we're going with 6.2. So you got another day to work on 6.1, and we'll get out of this, and I will shut this off. And I'll take the roll right quick.